Good afternoon, everybody, and welcome to this webinar, which title is the Industrialization and of the synchronous and asynchronous stator from design to the implementation. The purpose of this webinar is to explore the main differences between the two most important winding design solutions, which is the distributed windings and the concentrated ones. I will guide you into different topics, which is first the choosing of the materials and its availability. We'll go into advantages and disadvantages with pros and cons of the two solutions, and we'll have also at the end a focus on the industrial production process. The aim of it is to give you, I would say, the main topics of the two solutions and the key points, the key words for the right choosing of the solution since the very beginning of the project for every for every electrical motor, which is its design. Kame is a company of 6 plants, basically. We have a turnover of 130 million euros. We are serving 17 different countries so far. And the production capability is of 5 million windings a year, which means 22,000 windings a day, and far 8 million die-casted parts a year, which means so it's 35,000 die-casted parts every day. The sectors which are serving are different, and we have as well pumps, electrical motors itself, gear motors, we have compressors, gates opening, high pressure water cleaners, and mobility. 6 plants that are all located in the same valley, which is not that far from Verona or from Venezia, so in the northeast of Italy, and altogether we have about 60 employees. This is a picture of the headquarters of our valley. Our mission, I will not go through every statement over there, is just focus on some keywords. First one is we constantly innovate our company, and about it, it's important to underline that Kame is really focusing on processes, innovation, so toolings, equipment, machine, but also on people. So we have training courses to have a continuous improvement or the right managing and good managing of the company, and to seek the best solution for our customer needs. The two keywords of this statement is co-design and proactivity. Our aim, our goal would be to have anytime cooperation with the customer, with the project, just based on our experience and know-how. And proactivity means that we are also trying to give in advance the right solution to the customer needs. Product range. We have basically two main divisions. One is the windings, and the second one is the die-casted, aluminum die-casted products. About the windings, we have basically two production range, which is the distributed stators. You have a picture on top of this sheet. And on the second picture, we have a concentrated stator. For the distributed stator, we are using both copper or aluminum rounded enamel wire. We have 27 automatic production lines and 32 semi-automatic production lines. For the production of the concentrated, for the brushless or BLDC stators, in the second picture, we have 4 production lines by needle or mandrel. We have also a very important division about the aluminum die-casted, and so we are producing the whole range for electrical motors from size 56 up to size 132. And also we are also following and managing the machining, so we can supply the complete components, so the complete stator in the housing, already machined, ready to be assembled, as well as the rotor with, including also the shaft. In regarding of the die casting, we have also third-party die casting, which means that we are not only producing parts by catalog, so with dies of property of Kame, but we're also producing some parts under the design of the customers, which are not really linked to electrical motors. The casting division is IATF certified, and here you can have a picture of the most significant products in Kame. Services. We have two main services. It is myself as R&D manager for the winding division, and in principle, my job is basically in design of electrical motors, also regarding of the optimization of existing motors, bench test for the characterization, the efficiency check of the motor, feasibility check of the brushless stator, and also the partial discharge test. My colleagues of the die casting division are mainly focused on the design and co-design of mold. This is made through CAD software and through this also simulation like Magma, and also they will follow also the whole project from the very beginning up to the production of the parts. Now we are going into the technical details. So the advantages, the first one is the advantages of the distributed windings. And for that, I would like to give you just the based information, and as well, I'm available for further question later at the end of this webinar or separately by email. And the first one is that lamination cut available from various suppliers. Just think about that only in Italy we have 5 partners for this cut, which means that you can easily find this cut from different suppliers, which is very the same or very similar. The second one is that we have a mature production process. Just consider that starting from the 60s, last century, we started to see the first semi-automatic production lines, and in the late 80s or 90s, the first automatic production lines. So the production process is really very mature. Then this is also this one, which is also important, is the standard equipment and the flexible production. It means that you have the possibility to have from the same cut not only one but also more than one production lines. It is very simple to jump from one type to another type, keeping the same cut of the stator as well with different lengths, but also you can change the pitch, the diagram, data, polarity, using the very same equipment and toolings. We have just going to other advantages of the distributed winding. We have also the cost. So medium, low process and production cost. Just think about that. If we have a medium-sized stator, in a few minutes you will have one piece ready, and we have also the possibility of using different rotor solutions. So with the same, basically with the same stator, you can use die-casted rotor, which can be aluminum or copper, and you can have PM rotors or lactase rotors. And this in this very short video, but you will have also at the end a longer one. You have a short catch on the production process. Actually, there are not only as well advantages on the distributed windings, but we have also disadvantages. Again, I have a list of the main disadvantages of this solution. And so first one is difficulty in obtaining high levels of efficiency. The current regulation is asking for high efficiency level motors, which is I3. And still with I3 is still possible to, by distributed winding, to get the goal. But we already foresee some difficulties when we will jump into I4 efficiency level, and when we go up to I5 will be not even possible by distributed winding, unless you will find some solutions on the rotors or on the electronic. Then difficulty in obtaining high power density. This is also an important question, particularly when the driver of a project is the weight and the size of the stator. Just to give you a rough idea, some years ago we had a pilot project with a consultant of us in regarding of jumping from an asynchronous motor up into a synchronous one, and which was the main topics of this pilot project. And the results were, just as a rough indication, was that the weight and the size of the synchronous motor was the half. And so when the size and the weight is a key point, the distributed winding probably is not the right choice. And as well as if you think about some special sectors such as the automotive or the e-bike, the distributed winding or the asynchronous motor cannot be probably the choice because of the weight and the size of the motor. Now we're going into the second design, which is second solution, which is the concentrated windings. Concentrated windings, I'm speaking basically of brushless stators. Again, here I will give you a list of the main topics of which are the advantages and disadvantages. For regarding of the concentrated windings, you have as well, the first topic is the efficiency level. The efficiency level that you can get with this solution is extremely high, and this is due to the to two aspects: to the short pitch of the winding, and also to the using of PM rotors with significant reduction of the losses. Second thing is the high power density. As I said you before, if you think about an e-bike and you have a very small available space, and also the weight is an issue, and in this case, this kind of solution is the right choice. So for specific project, is the only one available choice. And as well as weight and size, as I said you before, it's how to say, a good driver for a choice for a project. We don't have only, as you can imagine, some advantages on this solution, and here you have some short video about this process in Kame, but we have also some disadvantages that have to be taken in account. Disadvantages are basically, the first one is, and this is the most important in my opinion, is that there are no commercial available parts on the market. It means that experience of Kame so far is that every project with concentrated winding is a customized project. So it is not possible to find available on the market the lamination cut. So when you think about the project, you have to think about the investment for the lamination cut. It is the second thing, it is a young process. We started seeing in the last century, in the 90s, the first production lines, and in this century, some automatical production lines. And also it is, just consider that on the contrary, we have also dedicated toolings. So for every project, you have to think about the dedicated toolings, unless you use the same stator cut with a different length as well. In this case, it is possible to make a kind of saving to have one tooling for different variant of types of stators. We am not finished on the disadvantages, because we have also cost. In regarding of process and product, unfortunately, the cost is how to say, big disadvantages. If I should compare from the process point of view the timing for the production of one concentrated stator compared to the distributed one, I would say for a medium-sized stator, so say for instance size 80, so 125 millimeter of auto diameter, we have from 5 to 10 times the production time. It depends as well on many aspects, on the size, on the specific of the project, on how complex the project is as well. But just to give you a rough idea. And in terms of cost, if I compare the same power, same performance, asynchronous to asynchronous one, with this technology, you should consider more or less 2 times the cost of the product. And another disadvantage is the using of magnets, mainly magnets. It is also possible to use reluctance rotors, for instance, to avoid the using of rare earth materials, but all the projects that came in Kame since 7 years are linked to PM rotors. So in regarding of that, you have to also to think about the cost of the magnets and also the sustainability for that. I'm quite finished, so I would like now to give you some, how to say, some indication at the end of this webinar. First of all, is this statement, which is, how to say, a statement of a friend of mine, which I do like. There is no one-size-fits-all solution, and the result of this statement is that there is actually not any time only one possible solution for a project. So the first suggestion that I would give to everybody is to have a list of all the drivers for the project. You have for sure cost, you have to think about investment, efficiency level, weight and size, and sustainability. And as soon as you have all the list of these drivers and a ranking of these drivers, then you have probably a better idea of the possibilities. I would recommend anyway at least 2 possible scenarios for any project before you will choose definitely which project will win. And third, which is last but not least, involve anytime the manufacturers. This is a very important key point, because we saw and we still see sometimes projects which are frozen from the customer, and when they come in Kame, we start immediately seeing some troubles and difficulties to have the right product. And it means that then we have to run behind problems to find solutions, which means so wasting of time, which means measure cost. And in the worst case, we also have the production, the project stop, because it is not possible, it's not feasible. So the recommendation is to involve anytime the manufacturer, which can be Kame or another partner as well. At the end of this that, I would like to share you this video just to give you again a view of the processes and the products. In this case, we are looking into the concentrated stators. This is needle technology, basically, and this is in the R&D area, basically for the design of the installation. But we can also have the 3D printing if needed. Just a short view in the testing and connection for the stators. But we have also a video about the distributed winding. We have a good experience in both in different solutions, such as for medium voltage, but also for low voltage. This is a very interesting video on the low voltage production with dedicated toolings. As well, we have the R&D and technical department, which is working with the customer in a partnership in co-design for the right choice of all the specific to get the good product. A short view into the production processes. So the connection, in this case, is the thermal connection of the terminal. The final testing of each product as well. We have a different stage of testing at the end of the line. Machining, as I said, we are able to supply with the complete stator ready to be assembled for the motor. If you need to contact us, you have here my telephone number and email address, but I would like also to, if we have still some minutes, And if you have any kind of question, you are free to put in. If you should have not enough time to answer, I will anyway come back later by mail personally to every kind of question or doubt. I'm just looking into some question which arrived in the meanwhile. One question is, will the BLDC motor definitely replace the asynchronous motor in future? This is a good question. We are thinking since many years about this question in Kame. And if you think about Kame processes, it is a very important strategic question, because if we should immediately jump into a definitive BLDC solution, it would be a problem for the whole supply chain. The result on that is that so far we don't see this dramatic changing. The asynchronous status, so this distributed windings, is still alive, is still produced in very high quantity. And we foresee that for some sectors it will be anyway the right solution, just because, for instance, the cost is one of the main topic. Another question, is Kame also producing hairpin stators, and which size? Actually not. We are so far producing only with rounded copper wire or aluminum wire, both for the distributed or concentrated. We have actually one open project on the BLDC stators using the flat wire, but hairpin is not yet property of know-how and production of Kame. It is a very, very dedicated and customized project, and also very expensive in terms of investment. Another question, this linked to cost. Which is the cost for a prototype of a medium-sized asynchronous stator, and what about a synchronous one? Okay, as well, I can only give a very rough indication, and thinking about a medium size, which is one of the most produced. So speaking of a stator of dimension of OD 110, 122 millimeter. If I think about asynchronous, so a distributed stator, just think about as an indication of 100 euros. If we jump into a BLDC stator, then you have to think about 10 times. And also this is linked again to the tooling, because for distributed stator, we have already all the tooling available. For the BLDC stator, as a consequence of the customized project, we have also to think about a small investment for the tooling. Also, if it is a temporary tooling, we have to play with that. So the cost is, say, about 10 times. Another question is Kame producing the PM rotors, so permanent magnet rotors, to in-house or externally? Actually, not. We are, regarding of the BLDC products, we are involved in the manufacturing of the stators only, not of the rotors. But again, we have open projects and open thinking about also to jump into the manufacturing and the supply chain also of the PM rotors, as we currently do with the die-cast rotors. Another question, so this is the last one, which is the investment to consider for a BLDC project? Investment. So if actually, which is the good strategy for a BLDC project, and again we are involved at this stage, we're involved in the stators. The good approach is to start with some laser cut, because we don't have the tooling. There is no commercial parts, so you have to think about some laser cut samples. You have to think about some 3D printing for the insulation cap of the stator. And because of that, we already jump into cost of, say, in between 1,000 to 2,000 euros, just to have a rough indication. Again, it depends on how critical is the project and all the specifics. If you then want to go into a more advanced stage, which is some smaller batches, then you have to think about a temporary die so stamping tooling. So the costs are rising up to probably 20,000, 30,000 euros. And then if you go to a definitive stamping tooling, you have again 10 times, so 200 or 300,000 euros of investment, just to give a very, very rough idea. I think that we are close to the end of this webinar. Anyway, as I said, there is no more time to answer to new questions, but I'm available to answer you in future. And if you have some question, I will come back as well by email. And I'm available here in Came for any doubt or any possible project to manage together. Thank you very much for your attention.